Mr. Shand. Afternoon. Mr. Shand.
Hey, Brit, hold on 1 minute, please. What's up? How are you?
I am well, thank you. How are you?
I'm good, thanks.
You're very hard to get through to. I don't like stalking you.
No, go ahead. Say it again.
I don't like our staff to stalk you.
It's all right. We know who you are.
Mm.
What's up?
I sent you an email. I
Just
don't know if
now?
you saw it.
Just now or earlier today?
No, man, earlier today.
All right, I'll look at it for you.
Alrighty, thank you.
Yeah, man, bless you, my dearest. Cool. All right, so the rest of you, good afternoon. Is only Amanda alone came on and said good afternoon, and I'm here before all of you. Only Amanda
Hi,
said good
sir.
afternoon.
Afternoon. Sorry
Me
about
no,
that.
me no want, wanna keep it. Wanna keep it a good afternoon. Only Amanda says good afternoon, sir, and that's why I responded to her. Hi, Amanda, and I'm here waiting. This is what time now. Because see, this is 8 minutes into the class session, and
Sir, what about
nobody.
the floor? We just want to join and I miss no.
Well,
Sir,
you
good
know,
afternoon.
oh, the afternoon coming now. All right, good afternoon, all. Yeah, man, water more than for true, man. Yeah, it's been a minute. There are so many things to be done. But yeah. All right, so I'll give you guys another 7 minutes, and then I'll begin at 5:15. All right, so get yourself sorted out, and I'll begin in a few. All right. By the way,
Yes, sir.
what was the last thing that we did again? Remind me. The indeterminate form, correct?
Yes, sir.
All right, cool. So what I'll do, I'll just generate some questions in the meantime while I wait on give you the 5:15 start time. All right, I'll soon come back then. All right, guys. Have you completed the first question?
No,
Have you
sir, I
completed?
wasn't class class, so I don't really understand him. So I'm waiting
Uh,
until you.
wait, sir.
Who,
Um,
okay. Go ahead, Crosswell.
all right. So based on how I see it, to factorize it, it will essentially become, how I would understand it, it would be x plus 3, and x plus 5, over x plus 3. And if we were to cancel out those two, it would become x plus 5. And
And if
since
you
this
play
is,
the music, turn off the music, please.
then
No,
I
he's
talk,
in he's in a public transport.
Oh,
right, so, and then it would amount to x plus 5. And when you substitute the limitation into the x, it would become negative 3 plus 3.
So the limit tends to what now?
It would become limited to negative 3, but and when you once you solve it, it would become, I think,
Yeah. So
um,
x plus 5, and you substitute in negative 3. So what would you get? X
negative
equals what?
3.
Really?
Um,
Negative 3 plus 5 equals
what?
2.
Yeah.
All right, cool. All right, thanks much. All right, you can mute Caswell.
Yeah.
All right, so he's correct. I know lots of you wouldn't, maybe did not hear what it is that he says or couldn't follow, but because I know what he's talking about, he's fully correct. Very good, Crosswell. Just always remember this and don't lose it. I'm going to do it shortly, but let me ask a question though. Anybody else has gotten an answer for the first one? Oh, there's something that you missed out, Crosswell, but I will deal with that one. Anybody got the answer for the first one? Anybody else? Somebody talk to me, no man. Either yes or no. Talk to me.
no, sir.
Okay, all right. Since it's a no, what we're going to be doing is we're going to be looking at the function. We're gonna again look at the limit. When you started the question first, what did you recognize? When you first started, what did you recognize? When you went ahead and did the substitution, what did you recognize? Somebody please talk to teacher, no man. Please.
Sorry, repeat.
Since negative 3 of x squared plus 8x plus 15. All right. So x plus 3. All right. So what is happening here? What is happening here is that you have the x squared plus 8x plus 15. X squared plus 8x plus 15. When you go ahead and substitute the value of x, what are you going to be assuming? We're using the calculations approach. We're using calculations approach. What are you going to be substituted into that function? Tell me.
Negative 3.
Say it again.
Negative 3.
Very good. So you're going to assume xv equals to negative 3. So it's going to be negative 3 all squares plus 8 times negative 3 plus 15 all over negative 3 plus 3. Now look at what is happening here. Negative 3 squares equal
9.
is equals to 9. Very good. And what is negative 3 times 8?
Negative 24.
Good job. plus 15. And what is 9 minus 24 plus 15?
0,
What is 3 minus 3?
0.
All right, good. So the question finished there now?
No, therefore.
No, sir.
No,
What
so
do you say?
therefore.
What do you say?
No, sir.
What it is a no, what statement will you make now?
Indeterminate
Very
form.
good. So now it is of an indeterminate form. It is of an indeterminate form. So now you know that indeterminate means, yo, there is something in this function preventing the true limit of the function from coming out. We now have to make the true limit come out. So one of three things, either a factorization, a rationalization, or a simplification. Either a factorization, a rationalization, or a simplification. So we now need to do one of those things. But when I look at the numerator, I see that I have a trinomial. So the first thing that comes to my mind is that I am going to try and factorize that trinomial. All right? So the trinomial is x squared plus 8x plus 15. 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 I'm factorizing that trinomial. Yes, Mason, I agree with you. Okay, so look at what is going to happen now. I'm going to say x squared plus 8x plus 15. I'm going to prime factorize my 15. 3 into 15 goes 5 times. 5 into 5 goes 1. So I need two numbers. When multiplied together will give me 15, but when added will give me 8. What two factors are they?
3 and 5.
Excellent. 3 and 5. Excellent. 3 and 5. So I'm breaking up 15 into 3x and 5x. Breaking up 15 into 3x and 5x. So look at what is going to happen now. I'm going to say x squared plus 3x plus 5x plus 15. Then I'm going to group to give me x squared plus 3x in one bracket. I'll always leave my middle sign out every single time. Then I'll ask myself the question, what is common in the first bracket that is common in the second one? So I will have x that is common here. What is left is going to be x plus 3. What is common in the second bracket? 5. Okay, what is left?
X.
X plus 3.
Good. What is common to both sets now?
X plus
Good job. And what is left?
X plus 5, sir.
Good job. So what it is that I'm going to do now, I'm substituting x squared plus 8x plus 15 for x plus 3 times x plus 5. I'm substituting those for x plus 3 times x plus 5. So look at what teacher is going to do now. I'm now going to write the limit as x tends to negative 3 of x plus 3 plus x plus 5. I'm making the substitution all over. Remember, it was all over x plus 3. All over x plus 3. So what I'm going to do, I'm going to say this cancels that. And then I'm going to be left with
X plus 5.
x plus 5. No, that is now a simplified form. No, if you once I have isolated what is causing the problem in the function, I can go ahead and work with it. Once I've isolated the problem, I can go ahead and work with it. So having isolated the problem, sir, what kind of problem I isolate? I now recognize that x plus 3 was my issue. Can anybody say that x plus 3 was the issue?
Yes, sir.
Yeah, man.
Yeah.
So now that I get rid of the x plus 3, what was causing the problem? And there are two things that you can look at. Two things that you can look at why x plus 3 was a problem. Because when you look at x plus 3, you'll recognize that if x is equal to negative 3, negative 3 plus 3 is equal to 0. You cannot have a 0 existing in the denominator. So right there and then it should give you some indication that the x plus 3 was problematic. You know, sometimes this is some friends and say, you know, say you're trouble, just stay far from me. Or it may not be a friend. It may be something out there. Say, you know, me not gonna use you because you are trouble. I'm staying far from you. That's exactly what this is, right? X plus 3 was problematic. We saw it from before. Well, I'm hoping I saw it from before. So I had to go ahead and factorize in order to get rid of it. Now I'm left with x plus 5. Now I'm going to apply my calculation by substituting -3 into the function. So anywhere in the function I see x, I'm going to put -3. So I'm going to now have -3 plus 5, and that is going to be equals to 2. So therefore, the limit as x tends to -3 of x squared plus 8x plus 15 over x plus 3 is going to be equals to 2, and that's my answer. Any questions? I'm seeing others showing that they move on all the way up to question 3, but I am doing this. I will do the other questions, but I want to give you enough time to work on this to make sure that you're fully understanding what is happening. So talk to teacher. Are there any questions? Are you seeing what is happening here? You want me to re-explain something? Is something not following, something not making sense? Talk to me. I need to hear from you students. There are many of you here. Colin, brother, you're not supposed to touch base with me.
Oh,
Me not tell you some
but
of the computer. Me not tell you some of the computer. Nah, come home and wait on the computer for me, bossy. Yeah, treat me so.
oh, you're serious? That
No,
was an
I mean,
example.
I'm serious. I tell you that the computer crash,
Oh,
and I need a computer. So I'm serious. All right, we'll talk. We'll talk off here. Yeah.
okay.
All right, cool. Guess Aquila.
Yes, sir. Good night again. I just
Good
wanted
man.
to know why we found the prime factor of 15 right there.
Why we found the prime factors of 15?
Yeah.
Good question, because we're prime factorizing. We are prime factorizing x squared plus 8x plus 15. You follow what I'm saying, honey?
No, sir, not really.
All right. So when remember when you have a trinomial is something with 3 terms. You know, for example, ax squared plus bx plus c. You know, and in general terms, it's going to be x squared plus 8x plus 15. That's a trinomial. And I'm trying to factorize that trinomial. So what I'm going to be doing is to multiply the coefficient of x squared, which is 1. Coefficient of x squared is a number in front of x squared. So I'm going to multiply the coefficient of x squared by the constant. And the constant there is 15. So 1 times 15 is equal to 15. 1 times 15 is 15. And then I am going to be prime factorizing that number. So when I prime factorize the 15, I'm going to be needing 2 factors. So I need 2 factors. When multiplied together will give me 15, but when I add those 2 factors, I will get the middle number. So it is a strategy. It's not just any 2 numbers I pick out of the bat. Not just any 2 numbers. It is I'm very strategic in finding that middle number. So when
And that middle number is 8.
and that middle number is 8. Very good. So I need 2 numbers when multiplied together will give me my product. Now listen up. It is not the last number that we're trying to find. It is a product of the coefficient of x squared and the constant. So I don't want anybody to look at it and say, oh, all right, I understand this now. So anytime I say the last number is the last number, sir, working with, no. Because I can give you a question where it is 2x squared or 3x squared or 4x squared or 5x squared. You must multiply the coefficient of x squared by the constant term. All right? So I'm only giving you the ones with x squared being 1 for now to boost your confidence. And then we're going to move into something a little later on where the coefficient of x squared is greater. Wait, Papa. The coefficient of x squared is greater. All right? So what it is that you need to look at is the coefficient of x squared. The coefficient of x squared is the number in front of x squared. The coefficient of x is the number in front of x. The constant term is that term that stands alone, is a standalone term. And the standalone term is going to be 15. So I'm multiplying the coefficient of x squared by that standalone term. So it's 1 times 15 equals 15. And hear my story, and I'm going to stick to it. I need 2 numbers. When multiplied together will give me that product, which is 15, but when added will give me the sum, will give me that middle term. The middle term is 8, right? So I'm going to have 3 plus 5 is equals to 8. Good. And 3 times 5 is equals to 15. Now, it must satisfy both conditions. It must satisfy both conditions. You can't just use it and it satisfy just one. If when you multiply 3 by 5, we get 15, but when you add it, you don't get the middle number, that can't work. It must satisfy both conditions. Am I clear there?
Yes, sir.
All right, good. So when you prime factorize, it is an easy way of finding those prime factors. It's an easy way because, sometimes the people them give things like 5x squared plus 15x plus 20 something. You're going to spend 5-10 minutes trying to find the factors and time is going. When you prime factorize, boom, 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 you get your factors in a jiffy. All right? Hold on a minute. All right. So now, so what we have is that 3x and that 5x. What I'm going to be doing is adding the 3x to the 5x, and then so that 8x I'm breaking up the 8x into 5x and 3x. Right? So I'm doing a breakup of something. That 5x and 3x I'm breaking up. Sir, which one to write first? It doesn't matter to me. If you want, you can write the 5x first. If you want, you can write the 3x first. It really doesn't matter. As long as you successfully break up the 8x into 2 factors, 3x and 5x. All right? As I said before, if we want to write the 5x first, it not really matter. If we want to write the 3x first, it really no matter. Right? Because 3 plus 5 is 8, and 5 plus 3 is 8. So it really doesn't matter which order you're adding them. And then what we do now is replace those, then I'm going to group. I'm grouping. So I am putting the first 2 terms in brackets, and I will leave out the middle term, and then put the last 2 terms in brackets as well. And when I do that, I'm going to get x in parentheses, x squared plus 3x. Then I'm going to leave out the positive sign. And then in the second parentheses, I'm going to get 5x plus 15. Hear my story. What is common between x squared and 3x? Answer that question for me. What is common between x squared and 3x?
X.
Very
X.
good. X is common. So I'm factoring all the x. I'm factoring all the x. So when I factor all the x, I'm going to check to see what is left. When I factor all the x, I'm going to see what is left. So what is going to be left is 1x, and then I'm going to have a 3. I put back my operation in the middle. That operation could be a positive, it could be negative. Notice all the questions I've given you so far, well, yeah, to date, those are positive. All right. And then now I will complicate it sometime later. And then now I'm going to have 5x plus 15. What is common between 5x and 15?
Sir, 5.
Very good. And then now I'm factoring out the 5. Since it's common, I'm factoring it out. And when I factor it out, I'm going to have another x plus 3 that is left. Amos, I hope that's a cell phone vibrating and it's not somebody crying.
Sorry, sir.
All right, cool. Okay. And then having done that, you're going to look now to see what is common. Check to see what is common right there for me. Look at it and tell me what you see that is common.
So the X.
Don't tell me just X alone. It has to be something else. Has to be something else. What is common
X
to?
plus 3.
Very good. So X plus 3 is common. So you have two terms. You have X times X plus 3, and you have 5 times X plus 3. So the X plus 3 is common. Now think about it. When you remove the X plus 3 from the first term, what is left? Hmm? When you
X
remove the
plus
first,
5.
no man, when you remove the first X plus 3, what is left? What is in front of the first X plus 3?
X, sir.
Right. Yeah, man. So you have X left. And then when you remove the second X plus 3, what do you have?
5.
5. So that means what you're going to have in the parentheses, knowing the other one is going to be X plus 5. So your factors are going to be X plus 3 times X plus 5. And that's what you're going to be using to substitute for the trinomial. So what it is that you're doing is factorization by grouping. So we've just factorized our trinomial. All right? And then what I've done, I've rewritten the question, but now replace my trinomial with x plus 3, x plus 3, the x plus 3's will cancel. And when I cancel the x plus 3's, what I'm going to be left with is x plus 5. Now, you see, after I have performed one of those simple operations, then I can go back and substitute my value. Only then I can go back and substitute my value. Only then. So when I go back and substitute my value now, and of course, we're using the calculations or the algebraic approach. So I'm going to assume now that x is going to be equals to negative 3. And then negative 3 plus 5 is going to be equals to positive 2. So all of that limit tends to positive 2. Tell me that you see what I'm talking about. Somebody talk to me. Are you good?
Oh no, that was me.
Oh,
Yeah. I just had to reconnect because of stuff.
yeah, man, I saw that. All right. So very good, Crosswell. I know you have that, but Crosswell, you have a tendency for know the stuff, know what to do, and then shortcut to something. Me not want a shortcut from you. I want you to write the stuff. You see my steps? They're about 5 marks or something like this. And sometimes on the exam, you get 4 of these to do. And they make you a piecewise function. 4 of these is 20 marks. 20 marks. And the whole question come to 30. And then find another 10 marker to give you. You went at the exam and you pick up an easy 30 marks right there. So I don't want anybody to shortchange anything there for me. Please to work it and give me everything in its entirety so that you can maximize the points. All right? Okay. I know based on what I'm seeing in the chat, there are some students who that gave me the solution for the other question, but the truth is, I feel uncomfortable doing the solution to the second question. I want to give students an opportunity, now that I've explained the first one, I want to give you an opportunity to answer that second question. So am I allowed to give you about 5 minutes undisturbed so you can attempt the second question and then I can come in and start working it? Can we do that?
Yes,
Yes,
please.
sir.
I just
All right.
here.
Right. So
Sir, do it
I
then,
under
sir.
no, give 10, me give 7. So I know that I see some of the answers in the chat, and because I generated the question, I know that those answers are right. But what I want to do is I want to do it in such a way that others get an equal opportunity to get a good understanding. So I'm gonna give you checking on you in 5 minutes, and then I give you an extra 2 minutes. All right, start.
Sir, can you go back up to the questions, please? So I can do it.
Sure, I'm going to do that, but the solution don't look like I can write, so I'm going to write it better. I am minimizing in such a way that you can see the whole question. Is that okay?
Yeah.
All right, cool.
Sir.
Yes, Derek. What's up?
Uh, yeah, I didn't miss last week Friday class.
Mm-hmm.
The is the link for that class available?
It is. I will be uploading those today. Um, there's another question that I need to maybe ask maybe the whole class, or maybe I need to talk to Colin, which is I'm asking Colin to help me out. But it will be sorted out. Let me just stick to Colin, and hopefully that something can sort out so I can upload the recordings. But were you able to follow through what I was doing just now with that question?
Yes, sir, but
Yeah, man.
I'm kind of distracted by the whole equations and when we see above when we miss Friday. I know I'm
Okay. Well, you see, that's why you can't miss
kind of low.
class. Yeah, miss class. I got go on with her not today, but so you can't miss it. All right. Just stay put. Just use the time then. Don't do the other question. Just use the time to just go through the first one, and then when I come back to do the second question, you should be in a better state to follow what is happening. All right.
Okay, sir.
All right. Cool. The rest of you, are we working okay?
Yes,
Yes.
sir.
No. All right.
Let's
Good.
see.
Okay. All right. Good. Good.
Yeah, sir, you get the answer, but you don't know if you're right still. But I'll just wait until the close.
What was that, Mario?
I got the answer, sir. But you don't know if you're right, so yeah, I will
Okay,
just
all right,
wait
no
until
problem, no problem. Yeah, all right, guys, I'll give you another 3 minutes, just to finish off that question, and then I'll come and work it here. But you have to try and do it. You don't sit back and
Sir,
just wait on me. Go ahead, JJ.
okay.
Yeah,
Sir, I'm
yes,
so
William.
sorry because I just stepped in.
All right, never mind. Just drop
So
everything
I'm
and
gonna
just
have to
quick and
play
fast.
catch up right now.
Yeah, man. Just drop everything and just the question, the example is still being projected. So just try something, even if you reach halfway. All right.
Sure.
Hold on. Hello. Go ahead.
Yes, sir.
Hold
Question
on.
number
Uh-huh.
4, right?
Question number who? 4.
4, sir. Question
Mhm.
right, sir.
Why ask if the question is right?
I just want to make sure that you know where you're right, sir.
Okay. So no, tell me why you ask me if the question is right.
Some kind of look for a negative, but the limit tends to.
Or you're looking for something that says, you're looking for something that says x is tending to -2.
Yes, sir.
Okay. All right. Well, if it is not tending to -2, work with what them give you. Don't go in an exam and go make up no question. So if it is tending to +2, make it tend to +2. Do you see the word tricky beside it?
Yes, sir. But get the answer, no, sir, but me kind of doubt that that's the answer.
All right. Hold on. Let me just calculate it quickly. What do you get? What do you get for the answer?
I get -3/4, sir.
And that is correct, sir. So stop doubting yourself, and that's why I put the word tricky beside it, right? So stop doubting yourself. All right, just stay easy. Let me give the others a chance to just finish the other one. But very good, Nigel. Love the effort.
All right, sir.
Cool.
Appreciate
All right. That is or was more than enough time to complete the second question. More than enough time to complete the second question. Nigel, I'm going to come back to you. Question 2. Okay, all right. I will check to see if you are correct. What is question 2? X squared plus 11x plus 28. And that is what? X plus 7. All right. Are you all with me? Hello, somebody?
Yes, sir.
Yes.
Okay.
Yes, sir.
All right. Now, so remember, when you're doing a question such as this, you have to go ahead and do your substitution. Remember, we're not doing the intuitive approach. So we're going to assume some stuff. The first thing we're doing is assuming x is equal to -7. So I'm going to have -7 all squared plus 11 times -7 plus 28 all over -7 plus 7. -7 squares is positive 49. Positive 49 plus 28, 40, 50, 69, that's 77. And then -7 times 11 is -77. So that's a 0. And -7 plus 7, that's 0, 0, indeterminate. I didn't write it up here. So indeterminate, it is saying to me that there's something in the function preventing the true limit of the function from coming out. Do you all agree with that?
Yes, sir.
All right. So now I need to do one quick thing. Simplification, a rationalization, or a factorization. So I look at the numerator and I see that I have a trinomial. I'm going to try and factorize. I'm multiplying the coefficient of x squared by the constant term. The coefficient of x squared is 1. So 1 times 28 is 28. I'm going to prime factorize 28. I'm going to do the prime factorization over here. My first prime number is 2. 2 into 28 goes 14 times. 2 is a factor of 14, so I'm going to go again with 2. Is 2 a factor of 7?
No, sir.
So I move to the next prime number. Is 3 a factor of 7?
No, sir.
So I move to the next prime number. Is 5 a factor of 7?
No, sir.
All right.
No,
So I
sir.
move to the next prime number, 7.
7.
I hope you see the gist of what it is that I'm doing. So it's going to be 7. And then 77 goes 1 time. So what I have now is 2 times 2 times 7. But I need 2 numbers. I have 3 numbers there. So it means I have to go combine some numbers. I only need 2 numbers. When multiplied together will give me 28. But when added will give me 11. So let's just try. 2 times 7 is 14. And 14 times 2 is 28. That's correct. But 14 plus 2 is 16. That don't work. Let us try 2 times 2 to be given 4. So let us use 4 times 7 is 28.
4 and 7.
And 4 plus 7 is 11. So that is a fact. Those are the factors, right?
Yes, sir.
So I know will write factors are 11. No. Factors are 7 and 4. So I'm going to break it up to say x squared plus 11x plus 28. I'm going to have x squared plus 7x plus 4x plus 28. What I'm doing, I'm breaking up my 28, my 11 rather, into 7 and 4. Remember, there's a method to my madness. You can't just break it as you please. It don't work like that. You can't just say, 10 and 1. 10 plus 1 is, no, you can't say 4 and, 10 and 1 plus 10 plus 1 is 11. It don't work like that. There's a method to the madness. All right, there's a method. Go ahead.
Does it matter if 7 is before 4 or 4 is before 7 in
Can
D3?
somebody answer Dejanay for me, please?
No. Yes.
No, it doesn't
No,
No,
matter.
it doesn't matter.
Okay.
It doesn't matter.
Yes.
7 plus 4 is 11, and 4 plus 7 is 11. It really doesn't matter. All right. Now that I've broken it up into that, I'm going to group now. I'm going to group. So I'm going to have x squared plus 7x in one bracket. Leave out the middle sign every time. Then I'm going to have 4x plus 28. What is common between x squared and 7x?
X, sir.
X.
And what is left?
X plus 7.
Good job. What is common between 4x and 28?
The 4.
And what is left?
X
X
plus
plus 7.
7.
Good job. What is now common between those two?
X plus 7.
Good job.
X plus 7.
Excellent. You see, it's only telling me the answer very quick, because you guys are seeing the gist of what is happening here, which is very good. So now I am going to have the limit as x tends to -7, and I'm substituting x squared plus 11x plus 28 as x plus 7 and x plus 4, and that is all being divided by x plus 7. What do you recognize right there?
X plus 7 cancels out itself.
X plus 7 cancels out. So now that I've cancelled out, very good. Now that I've cancelled out my x plus 7, I'm going to be left with x plus 4. And then when I substitute
Well, I
-7,
blink. Where you get the second X plus 7?
that's the denominator,
Oh,
Colin.
denominator. Oh, okay.
Right. And then now I'm going to have -7 plus 4. And -7 plus 4 is going to be equals to
-3.
-3. So I can now safely say that the limit as x tends to -7 of x squared plus 11x plus 28 all over x plus 7 is going to be equals to -3. And that's my answer. I know for you, you're seeing it a little clearer now. It may not be fully there yet, based on the questions that I were asked while I'm doing this. You have another opportunity for another question, which is question number 3. This one, I deliberately put a negative sign there. Am I allowed to give you 5 minutes to do this question, please? If you're finished with it, that's fine. But there are some students who are needing the help in getting this thing done up. Yes? No? Maybe so? Can I give you 5?
Yes, sir. I would appreciate it.
All right, good job. Amanda, is it Amanda? Amanda, where you stuck? Because I don't. Oh, you're right. That a while ago. Sound like frustration. What happened, Amanda?
So you're hearing me?
I'm hearing you now.
So I'm stuck at number 4.
Oh well, girlfriend, you're all the way ahead of everybody. Just tell me the answer you got.
-3/4.
Yeah, you're not stuck. You finish it. Very
Oh,
good. Yeah, not a thing wrong with Amanda. Very nice. All right, the rest of you, 3 more minutes, and then we're gonna come in for question number 3. Colin, how you stay?
Oh, I mean, I get you, sir.
Okay, good job. Sounds good. All right. How far are you? Like about 1 minute away, 2 minutes away?
Maybe two to three.
All right. I give it those 2 to 3 so that you can finish off. Guys, if you're finished, just look over. And if you're finished, just jump to question 4. 2 students already complete question 4 correctly. Stop doubting yourselves. Amanda and Nigel in particular. And just do the stuff. Just move on to 4 if you're finished with that for me, please. If there is time, I could move on much faster than this, but I really don't want to rush through the stuff. I want to make sure that you're understanding. So if I feel comfortable, I may give you another version of it, but I just want to make sure that you understand this. All right. So 2 more minutes.
Sorry, before I move on to question 4, is the answer for 311?
For 311, I soon tell you, I can check it.
Okay, so
Sir,
Yes, please.
for number 4, x is tending to what?
Positive 2. Yes, it looks, based on a quick calculation in my headspace, it looks like it's 11, I think. 6 and 5, 11? Yeah, I think it's 11. Yeah, it's 11.
Yes, sir. That's what I just got as well.
Nice job.
Thank
Good job.
All
See, you guys are learning. Very, very, very good.
I sir, we have to see your workout that one day, sir.
No problem. I will do that. I'll do that in a few. But yeah, man, very good. Students, as I said before, it's the first in this long time I'm seeing so many. I have so many calculus 1 students. And I know there are 1 or 2 students in the class now that are struggling, but you're either I'm afraid to say this, but anyhow, you're either pride or your ego is preventing you from saying that I do not understand. And that is going to be your failure. As opposed to say, sir, I do not understand. Allow me to say, meet me outside of class so we can talk about it. But I will go through. I will definitely go through so that you can understand. I really want you to understand what is happening. But if you don't speak to me, I won't know how to help you. All right? So just saying that out there. Colin, you have 1 more minute. And then I'm going to do number 3 and then 4. All right. So now, this one is x squared plus x minus 30. X squared plus x minus 30. X squared plus x.
To write the wrong question as usual, sir.
You
Don't
can't,
ask.
you can't do that, man.
Don't ask, sir. Don't ask. I rush too much.
X squared plus x minus 30. And this was x, what is this? X minus 5. Leave it as it is. If the denominator,
Also, let's
if the denominator is not 0, chances are it's not well, not chances are. If the denominator is not 0, it is not indeterminate. So if the denominator, and that's why I give it that question, because I wanted to bring across that very point. If the denominator is not 0, leave it as it is. Whatever you get, you get. Don't interfere with it. Whatever you get is what it is that you get. Fair enough? It's very important that you understand that, though, guys. Very, very important. Very, very important. If you if the denominator comes out to be 0, chances are it's indeterminate. But Nigel asked a question, Amanda asked a question, sir, I kind of stuck at number 4. If the denominator is not 0, it's fine. If the numerator is 0, it's okay. The numerator can be 0. But if the denominator is 0, you know, it's definitely indeterminate. If the denominator is not 0, chances are you don't have that and you can continue working. All right, hold on a minute, please. All right, so now, what we're going to do is substitute our x. We're going to assume x is equal to 5. We're assuming you're assuming that x is equal to 5. Anywhere in the function you see x, you put 5. 5 squares plus 5 minus 30 over 5 minus 5. 5 squares is 25 plus 5 minus 30 over 5 minus 5. Is that 0 over 0? That's the indeterminate form. Are you with me or you are otherwise engaged?
Yes, sir.
All right, good job. So now, because it's indeterminate, I must find something. A rationalization, a simplification, or a factorization in order to minimize that indeterminate form. So I recognize that I can factorize the numerator. So I'm going to have x squared plus x minus 30. The coefficient of x squared here is 1. So I'm multiplying 1 by the constant, which is 30. 1 times 30 is 30. And I'm prime factorizing 30. 20, 30 goes?
15.
Can I use 2 again?
Yeah. No.
No, sir.
Yeah, use 3.
I have to move to the next prime number. Next prime number is 3. So 3 into 15 goes?
5.
All right, can I use 3 again?
No, sir. 5.
I have to go to the next prime number. Okay, 5. Very good. So you're seeing the gist now of my multiplication. I need 2 numbers. 2 numbers. When multiplied together, will give me negative 30. But when added, will give me a positive x. So I can do 5 2 is 10. I can say negative 10 times 2. That is equal to negative 30. But when I add it, I'm going to get negative 8. That can't work. I can say 3 times negative, no, what I'm talking about, 10 times, and nobody could
We get
correct
the
me.
10, sir.
Huh? Oh, I get a 10?
We get
So
the 10.
see it
The
about
5 times the 2.
everyone so done. The
The
2
5
and the
times the
30.
2. I have to manipulate it. I only need 2 numbers. I have 3 numbers there. So I have to manipulate those numbers. I have 3 numbers and I only need 2. Hold on 1 minute, please. All right. So now, I could say also 6 times 5. And I could call this negative 6 times 5. Negative 6 times 5 is 30. But when I add negative 65, I'm going to get negative 1. But I don't want a negative 1. But hold on, sir. Hold on. What if I say 5 times negative 6? It is still 30, negative 30. But when I add it, I'm going to get, oh, come on. When I do it like that, negative 5 times positive 6, I'm going to get negative 30. But when I add it, I'm going to get positive 1. Have I found my factors?
Yes, sir.
Good. So somebody was asking how I got the 6. I am simply grouping some terms. So this 2 times this 3 will give me the 6.
Oh, I didn't know you can multiply them.
Yeah, man. Remember, you know, only 2 terms you want, you know.
I thought
I-
you would have to add.
No, man. Yeah, multiplying. So it's 2 terms you can't add because remember, you know, when you get your factors, this must multiply to give you negative 30. So factors now are
Sir,
yes, please.
is this why I deliberately added the negative?
Yeah.
Ah,
So that you can see that, you know, life is not life in sometimes and you can get negative numbers. All right, watch me now. So factors are going to be negative 5 and 6. I want to be close to this, guys. Stand close. Watch me. All right, Maya, just take your time then. Just take your time, my love. All right, watch me here. So I'm going to say x squared plus 6x minus 5x minus 30. I'm going to group. I'm going to get x squared plus 6x plus 6x. My pen not writing. Plus 6x in one bracket. Always minus what? Open bracket what?
5x
Uh-huh.
minus 30.
Give me a plus 30 now. So let me give you a story. It's when you have a negative sign in the middle. Show it some respect. Flip. What is wrong with this pen? We're going to flip the last sign.
Okay.
Right? And why? Look at why you're doing it. They're flipping the last sign. Look. Remember, there's a negative 1 here now. Negative 1 times positive 30 gives me what?
Negative.
Negative
1
30.
times
Positive 30.
Negative 30.
I see the negative 30 right here, so.
So you're not hearing me attack.
I heard you, Mason. I heard it. I heard you. All right. And then besides, there's another condition to that. Besides, whatsoever sign that is right here, so, has to be the same sign that is right here, so. You may not have seen that. When you group it, same sign here, so, same sign here, so. When you group it, same sign right here, so, same sign right here, so. So after a group, and the signs are not similar, something wrong. Signs must be the same.
And this is all the time, sir.
Yes, absolutely. I'm going to tell you, if it's not all the time, it means that you couldn't factor it out. Because if it wasn't that, it means that this sign would have been one of the signs down here in the x plus 3, where you have the 2 x plus 3, it means that one of the x plus 3 would have been x minus 3. Talk truth.
Seeing it.
Yeah, man. And I couldn't factor out an x plus 3 from an x minus 3 like that. Because nothing would be common. And if you're factorizing by grouping, it has to be something that is common. So every time it's going to be like that. Every single time. So the signs must be the same. If the signs are not the same, you're going to be in problems. If the signs are not the same, you're going to be in problems. So you have to make sure that the signs are the same. All right? Now, hold on a minute, please. All right, so let's go now. What we're doing, we're going to be doing our factorization. What is common between x squared and 6x?
X.
Good job. What is left?
X.
X plus
Six.
6.
Oh, good. And what is common between 5x and 13?
X.
5.
No. 5.
5.
What is left?
X plus 6.
X plus 6.
What is common between all of those now?
X plus 6.
Good job. What is left?
X plus 6 and X plus 5. X
X
minus 5.
minus 5.
Okay, thank you, sir. So now I'm going to, oopsie daisy. Now I'm going to rewrite my question to read the limit as x tends to 5 of x plus 6 times x minus 5 all over x minus 5. All over x minus 5. Now, what do you recognize here?
X minus 5
denominator
cross
have
cancel out.
the same factorization.
That good job. All right, so what I'm going to be left with now is x plus 6. And then as the question was asked, 5 plus 6 is going to be equals to 11. So therefore, the limit as x tends to 5 of x squared plus x minus 30 over x minus 5 is going to be equals to 11. Are you a little bit more comfortable with that?
Sir, I did it another way and got the same result.
I know. There's another way, but I decided to do it the harder way to show you how the negative sign can come into play. What you did, you started off with, I can guarantee you what you did, you started off with x squared minus 6x plus 5x minus 30 down.
Sir, when I factorize it, I had x squared minus 5x. So when you put the 6x first, I had a 5x first, which would give me double negative signs.
Should give you what? Double negative signs?
So basically,
Say it
when
again,
you
which will
put the
give you what?
6x, no, I would say like when we're multiplying the x plus 6 and x minus 5, right there, so sir, I have two negatives instead of the two positives, or two minus signs rather, if you're following.
Say what? No. I am following, but that's not correct though. We have two minus signs.
Type it out in the chat so you can see.
Yeah.
Sir, after that, right, after that, show some respect for the signs, right? What is that script that you have there?
Oh, yeah.
Flip the last sign.
Keep, is that keep?
Flip.
Okay, thanks.
Waiting for you. For what it is that you said that you did.
Sure,
So I
send
can.
it to.
You send it to me?
Yeah.
Yeah, that's what I said. So you'd have to put your negative sign first instead
Yeah.
of right. Yeah, that's exactly what I said. But you said no, sir. That's not what it is. Right.
Okay.
So you
I
are.
guess I was explaining it wrong.
Mm-hmm. So your middle sign then will be a positive sign as opposed to being a negative
Yes.
sign. Right.
Yes.
Right. Yeah. So that is correct. So both ways are correct. The method that I just used a while ago is not as smooth as that one, but I did it one deliberately to show you how to work the negative sign. So I was deliberate to put the negative one second instead of putting it first, like you did. All right. Any other question?
Sir, I'm finally catch up.
Good job. Any other question? Guys,
Yes, sir.
talk to me.
Question.
Go ahead.
All right. So at the negative 30 part where I factorizing, yeah? You had put negative 5 times, what was that? Negative 5 plus 6, yeah? And that gave 1, right? At the prime pairing section, yeah? So 1 would equate to the 5 because we're going to substitute the x for the 5. If you understand what I'm trying to say.
No. Say it one more time.
All right. So why did you use the negative 5 and 6? That's my question.
Those are the factors.
Right.
Of
and
negative
that equates
30.
to 1. Yeah.
No, don't say that. No, stop. I'm looking for two numbers. When divide will give me negative 30, but when added will give me a positive 1.
Okay.
So when you see me with the negative 5 times positive 6,
yeah,
that will give me negative 30 when I do the multiplication. But when I add it, I will get a positive 1. So that's the one that my factors are negative 5 and positive 6.
Okay, sure. All right, thanks.
Any other questions? All right. I'm respecting the fact that it's now 3 minutes past. I'm not going to go through the last question. What I'm going to do is I'm going to try and generate some questions and send off for you so that you can have those questions to do in class for me on Friday, God's willing. But students, today for me wasn't a bad session. What it says, however, is that some of you were not understanding what was happening. One person said that Sarah wasn't here, and therefore it kind of put him off. See if you can, as best as possible, student, turn up for the sessions. And also, when you turn up for the sessions, I want you to really turn up. You don't multitask, you don't gallivant, you don't waste time, because this teacher is moving. We have quite a bit to cover, and I don't want to leave you hanging. All right? So I guess we talk on Friday. Have a good one.
Sir, where are you sending questions? You send them on Friday?
No, I'm going to send the questions before Friday.
Hold on there, sir. You never want my help.
Yeah, man. Colin, drop your number in the chat for me, please. So you can send it privately. You can send it directly to me. So I'll link up with you so we can make some arrangements.
Evening, sir.
Hi, how are you doing?
What I'm going to ask you to do for me, please, is actually the work number 4, and I heard other two's got the answer, and I got that answer also. But I was just here trying something else.
Why?
No, I got the same answer as them, no, sir. But what I want to ask you to do for me next class, so if you can just factorize that. All the doesn't need to be factors, must ask to show me how you would factorize that factorize, sir.
All right. But you understand otherwise zone?
Yes, sir.
All right, Zidane. Pick up yourself later.
Okay.
Cool. Is there another question?
So a number in the chat. Send it to you.
Yep, man, I see it. I soon ding. All right, thank you, Colin.
So, sir, once we
All
log
the
in on Friday, we'll see the questions.
So you'll be sending the other questions by tomorrow or so?